equals ln4 look like?
The opposite.
Okay, it's ln of 4. 4 is a number, so the ln of 4 is a number, right? Now, do you know what it is? Probably not. That's okay. Boom. X equals ln4. Okay, then we want to stay in the first quadrant, so that means we are shading right here. Yeah? We a little bit remember this so far?
Yeah.
Okay, then what are we revolving around?
The x-axis.
Okay, it says we're going about the x-axis, so that's this right here. Okay, I would be spinning this around the x-axis. That would give me kind of like a tubey thing, okay? And then your radius would run from here to here, right? Top minus bottom. So what would r of x be? What's on top?
The y to the e to the x.
E to the x. And what's on bottom if it's the x-axis?
0.
0. Good. Now, do you have to put the 0 again? No, you don't have to. Okay, so volume equals pi integral r squared, where r is e to the x. What are my endpoints going to be?
0 to ln4.
Good. This is x equals 0. This is x equals ln4. So those are my endpoints.
That's it. That's it.
That would be if you're just setting it up. We are going to work this one out to make sure you've seen some examples. So what would you do with x, e to the x squared?
E to the x times e to the x.
Okay, you could do that. We need to simplify. What do you do with exponents when they're both up here already? Do you add them or multiply? Multiply. So that would be e to the 2x, 0, ln4. Okay? If they both had their own e, you would add. So if it was like e to the x times e to the 2, that would be when you add. But if it's an exponent squared, you would just multiply. Okay, from there, what is my method going to be here? Okay, what's chain rule called though for integrals? You know it.
Use that.
Good. U is 2x. That means that du is 2 dx. That means that dx is du over 2. So far, so good? Okay, I'm going to take my over 2 and put it with my pi here in the front. So that's going to be pi halves e to the u, du. And then I have to remember to take my endpoints and plug those in as well. So if it's a 2x, what is 0 plugged into 2x? What is ln4 plugged into 2x? ln4 times 2 or 2 ln4. Very good. Okay, from there, what is the antiderivative of e to the u?
E to the u.
Okay, so I'm going to keep my pi halves in the front. E to the u is what we're plugging in. And then we're going to have ln4 and 0. 2 ln4 plugged in would be e to the 2 ln4.
Did the ln cancel out?
They are going to cancel out, but they can't just cancel out right now. Okay, then for my 0, what would I get? 0?
E to the 0, which is 1.
E to the 0, which is 1. Okay, let's deal with the e to the 2 ln4 for a second. You cannot cross out e and ln if there's something between them. So do you notice here that this 2 prevents these from crossing out? But remember, ln's, you're allowed to move that number. Where are you allowed to move it to? Well, it's already in front. We want to move it here. You cannot see that, sorry. Okay, that 2 jumps up to be an exponent. So remember, that's one of your rules with ln's, is that if there's a coefficient in the front, you can bump it up to be an exponent. And now from there, it's e to the ln. Now they can cross out. Yeah? So this guy and this guy, gone, gone. Now it's just 4 squared. What's 4 squared?
16.
Yep, 16. And then what do I do with those endpoints?
Subtract them 15.
So it'd be 15 is my final answer?
No. Times pi over 2.
Yeah, 15 pi over 2. Okay, and that would be your volume. Remember that? Okay, good. All right, I'm going to skip the next one just because I don't want us to not have time to finish. Well, no, we'll go ahead and do it. Okay, 2y plus 2. Where is it going to start at? On the x-axis, 2. And then if you're not sure which way the line goes, remember, you can set it equal to 0 to solve. So what am I finding right now? If I let x be 0, I'm finding the y-intercept. Okay? So if 0 is my x, then 2y plus 2, I need to subtract the 2y over, and then divide by -2. What do we get for our y? -1. So that means that that's the other point my graph hits right there. So my x-intercept was 2 because it was in x equals form. My y-intercept is -1. Then it says, read your thing, I want that line, the y-axis, and y equals 3. So y equals 3 would be here. So can you see that's going to be a triangle shape? If I shade all three of those things. So I have my line, my y-axis, and my y equals 3. Right there. Okay, now read carefully. What are we revolving around? Y-axis, that's right here. So that means that that is going to be the center of my revolution. It's going to go around this way. So I'm going to end up with the other side over here. And remember, for dy questions, your radius runs sideways instead of up and down. So when I draw it in right here, my r is going to be right minus left, but on the right side it's 2y plus 2, and on the left side it's 0. Questions about that, or does that all look pretty familiar? Familiar? Okay. Then from there you do volume equals pi integral 2y plus 2 squared. You have a question or no?
I do.
Okay.
I'm trying to figure out what my question was.
Okay.
Why don't you add the 3?
Because...
Is that considered like right to left because you're still touching it?
Yeah, because when I draw in my radius, I'm not touching 3. Where's 3? Way up there. Now, 3 is going to be useful. When I set up the boundaries on the integral, I'm using y values. So what is 3 going to be on the integral? 3 is the top, and what's the bottom we found? -1 to 3. Okay? Then you would do u sub on that, blah, blah, blah. Hopefully you can do that. If not, then we got to practice more, but we're not going to do it right now. Okay, so questions about that. It's pi r squared. You draw in your r, and that picks whether you're doing dx or dy. Okay, what you just learned is called disk method. Disk, we'll put method. And the reason why is because in both of those graphs, your region was adjacent to the line you revolve around. Okay, so let me explain what I mean by that. If you are adjacent, what does that mean back in geometry?
Next.
Okay, next to, but can it just be touching in one spot?
Yeah.
It has to completely share a side.
Is it not perpendicular?
No, doesn't have to be perpendicular. So this is what I mean by that. Look at your axis here. Does it share a side with the shaded region?
Yes.
Adjacent. Look at this one. Do I share a side with this line?
Yes.
Yes, then I'm adjacent. If you're not adjacent, you might touch at 1 or 2 points, okay, but if you're not fully connected to that region, then it is not adjacent. Let me show you what I mean. Okay, and because the cross-section is a circle. Okay, the method that we're going to learn today is when you have a gap between your region and the line that you're revolving around. So, right here, set up a graph. Okay, let's say that you have a graph like that, and then a line. And I want to rotate this region right here, I'm highlighting it for you. I want to rotate that around the x-axis. Okay, question, am I adjacent to the x-axis? No. If I rotate this around the x-axis, you should notice that you have this whole big space. What that means is that you're going to end up with a donut as your cross-section. Now, this is what I mean by that. Try to draw like a little reflection down here. okay, of the other side of your region. So it would look like that. And then as you rotate that around, what you're going to notice is that if you were to slice it, you would have a donut as your cross section. It'll look like this. You'll have an inside radius of hollow crap, and then you'll have an outside radius of the whole thing. Now, I have found a computer thing to show you that a little bit better, okay? So I'm going to put it up here, and hopefully this will help. Okay. Let me make this go away. And then okay, you see you have a region here? Yeah? Okay. We're revolving around the x-axis. Look what happens. Okay, are you watching? Look. It revolves around. Notice you have that whole hollow part in the middle. And so when you twist this, do you see how it's kind of empty in the middle? Okay, so that is called washer method. Okay? So you'd have your outside part, and then the middle of it is like kind of hollow looking. Does that make sense? A washer has a, okay, now for my ladies here, okay, or maybe, I don't know, maybe some of y'all know this. Okay, washer like goes with like a nut and a bolt, and it like has a hole in the middle. I call it donut method because who doesn't like donuts? Okay, but a washer, okay, is just like a little thing with a hole in the middle, okay, which I never would have known ever until this came around. So, here is your shape.
use it in science.
Huh?
Yeah, we use it in science.
I mean, maybe I did, but I didn't like think about it.
Right? That's all we do.
Fine, maybe it occurs in other areas. Okay, but I would just probably call it like a circle thing. And you have the circle thing, give me that metal donut, you know, it's totally fine. Okay, so here's why this matters. Okay, here's why this matters. Instead of only having one R, you're going to have two R's. Okay, so here's the difference. Your capital R is going to go from the farther away graph to the axis of revolution. We're going to call that capital R. And then your little r is going to represent the circle in the middle, the empty one. So it would be right there. So capital R goes from here to here, and little r goes from here to here. Now, do you notice that they're still both top minus bottom?
Yes.
Okay, so I'm going to put r equals top minus bottom for the longer radius. And I will usually say the outside border. Okay, so I want you to know what I mean by that. Outside being like the outside of your three-dimensional shape. And then little r is going to be top minus bottom for the shorter radius. And instead of the outside boundary, that would be the inside hollow part. The inside border. And now think about, if I find the volume of the outside, and then I find the volume that's missing from the hollow side, how could I find the volume left over?
Subtract them.
Subtract them. Very good. Okay, so the volume is going to be pi integral a to b, and then you're going to do the big R squared minus the little r squared dx. And what that's going to do is it's going to find your whole shape, and then it's going to minus the hollow part out of the center.
This is so much unnecessary work.
Yep. But it's the last new thing, okay, on the bright side. So, turn over. Let's do some
Do we hurt your
examples.
feelings when we say things like that?
Nope. Not at all.
I feel like to make a face that we do. She kind of like. I felt saying.
Like I look like I'm crying on the
Are
inside.
you consider? Are you maybe you're just not as sensitive as me?
Yes. Just call me Pythagoras.
Oh my god.
Just kidding. Please don't ever call me that, especially if people are close by. Okay. Look at your graph. Or look at your equations. You have x squared plus 1, y equals 1, and then we're going from 0 to 2. So let's graph that first. So x squared plus 1 would be here. And then y equals 1 would actually be below that right here. Now, those don't cross again, so how do I know where to shade from?
It's an x-axis.
Okay, that's what I'm revolving around. How do I know where to shade from now?
Because 0 to 2.
0 to 2, good. So I'm going to start shading at 0, and then I'm going to shade all the way until wherever 2 would be. We'll just say it's right there.
Okay, my question
Okay.
is why can you not do it beneath the y equals and on top of the whole area?
Because that wouldn't be between the curves. Yeah? Okay, so now think about, what am I revolving this around?
The x.
The x-axis. Am I adjacent to the x-axis?
Not at all.
No, I have this huge gap. So draw in your two r's. Capital R should go from what you're revolving around to the farther away equation. So this is capital R. Because it goes to the farther side between the top and the bottom. Little r is going to go from what you're revolving around. Remember, this is going to be the middle as it rotates to the inside border. That's little r. But remember, how do you find them? It's top minus bottom both times. Now, the bottom here is going to be the x-axis, which is what? 0. So for capital R, what is the top of capital R here? Which equation?
Where not
X squared plus 1. And then what is the bottom of that radius touching?
0.
0. Okay, because it's the x-axis, yeah? Okay, little r is going to be the top of R to the bottom. What's the top of R here? 1. And what's the middle? 1 minus 0. Okay, obviously the zeros we're not going to write, but you could. Okay, where am I going to integrate from? What are my x values?
0 to 2.
Good. Volume equals pi, integral 0 to 2. And then it would be x squared plus 1, not writing the 0, minus 1 squared, not writing the 0. And then you're done. So instead of 1 pi r squared, you have pi r squared minus r squared. Yeah? Okay, go down to the next one. Let's sketch a graph. And then just to make this one a little bit easier, actually, I'm going to change this to just y equals 4. Okay, to make this easy. So y equals 4 would be a flat line. And y equals x squared is a curve. Okay, you see your region pretty clearly here? It's going to be like that. Where are those graphs going to intersect if it's y squared equal to 4? Yeah, positive and negative 2, right? So this would be x equals negative 2. This is x equals positive 2. So far, so good? Okay, what does it say we're revolving around? Revolving around the horizontal line, y equals negative 1. So is it going to be the x-axis this time? No. So draw your y equals negative 1 down here. That is the middle of the region. Draw for me 2 r's. 1 r should go from the green line to the farther away border, and the other r should go from the green line to the closer border. So I'll give you a minute to kind of think about it, and then draw them on your paper. So capital R should go from the axis of revolution that you're revolving around to the farther away line. That's capital R. Do you get it? Okay, then your little r should go from the green line to the inside function. But do you notice they're both top minus bottom? That's normal. Okay, so capital R, what is my top minus bottom for my equations? Y equals 4 minus y equals 4 minus negative 1. Now really that's 4 plus 1. 4 plus 1 is 5. Now question, does it make sense? Think about your picture here. What is the distance from 4 to negative 1? 5. So that makes sense. And then also think about if it's flat, then it's just always 5. It doesn't matter. Okay, now look at your little r, top minus bottom.
X squared minus 0.
It'd be x squared minus what? Negative 1.
Why?
Because what's on the bottom? Remember, this is 0. We passed 0, we went all the way to negative 1. And then from there, we could change that to x squared plus 1. Then what do we do for our integral? We do volume equals pi. Where to where?
Negative, no,
Negative
2 to 2.
2 to 2. And then remember, capital R gets to come first because it's bigger. So it would be 5 squared minus x squared plus 1 squared. Make sense? Okay, good. Alright, one more like that. 4 minus x, what does that look like? We're going to do 2 pictures, so put your picture like more on this side. 4 minus x, where does that start?
At 4.
Okay, it starts at 4. Which way does it go if it's a minus x?
Down.
Down. So there's your region. Okay, and it says I'm going to go between that line and the x-axis and the y-axis. So that'd be this little triangle. Okay, first thing it asks you is to revolve the region around the x-axis. Are we adjacent or sharing a side with the x-axis?
Yes.
Yes, so how many r's are you going to have?
1.
1, because when you revolve this around, do you see that there's not going to be any gap in the middle? So that would be considered disk method, because there is no hole in the middle. Okay, so this is disk method. That means that you only have 1 r, and it's going to be top minus bottom. What's on top? 4 minus x minus 0. Then when I set up my integral, if this has a slope of negative 1 and it started at 4, where's it going to hit here? 4. Good. Because you're going down 1 over 1, down 1 over 1, right? Then you do 4 minus x squared dx from 0 to 4. Boom, you're done. Got it?
No, it's a disk.
You know it's a disk because your green line is adjacent to the region. There's no middle part that's empty. Yeah, there's no space in the middle. There's no gap. Okay, now we're going to redraw our picture. So put your little thing here. We know this is x equals 4. But what are we going to revolve around this time, it says? Y equals 4. So if I draw in y equals 4, am I adjacent to that line? Yes or no? No. Now, does it touch at one point? Yes, but that's not the same as adjacent. So draw for me on your paper. I'll draw it in a second. But draw your 2 r's. Remember, capital R should go from the green line that you're revolving around to the farther away side of the region. And then little r should go from that green line you're revolving around to the closer side of the region. Okay, so hopefully you got it right. Your capital R should go from here to here. And then your little r should go from here to here. Did you get it? Okay, now write top minus bottom for both of those. So capital R is here. What's on top? 4. What's on bottom? So capital R is 4 minus 0, which is really just 4. Okay, little r, top minus bottom. The top is still the green line, but what's the bottom now? 4 minus x. And what's going to happen there? Well, what's going to happen with these 4's? If I do 4 minus x, they can cancel out. So is it just negative x left over? Positive x, because of the double negatives. Yes?
Is it that little r on the x-axis to linear line?
Because we're not revolving around the x-axis. Remember, one of your sides of your r has to be touching what you're rotating around. So if we're rotating around y equals 4, then that's your center line. And your solid would be formed going around that as your middle axis. Okay? And then from there you do volume equals pi integral 0 to 4. 4 squared minus x squared dx. Okay, and that would be called washer method. Yeah? Okay. So you can do the same thing dy, which is what we're going to do next, unless y'all are super confused. Is everybody doing okay?
No.
Are you just being dramatic?
I'm
Just a little dramatic.
Be able to visualize, how do you know it's a donut? And
Remember, you're looking for whether you're fully touching the region or not. Okay, so let's set up 1 or 2 dy, and then look, our plan for the rest of the week is to keep working on this. So once you get it, this is your last new thing and you learned it. Okay, here's the difference dy. Your volume equals pi integral c to d, where c and d are what? They're y values. Very good. Okay, what do you think your equations have to be in terms of? Okay, your equations have to be in x equals form. So your r's will be r of y squared minus little r of y squared. And then the other thing you have to remember is that instead of your radius line being top minus bottom, what do you guess it'll be? Okay, your radius are going to be right minus left. Now remember, let's say that you forget and you put them in the wrong order. If you square it, that's not going to mess you up. It really doesn't matter. Okay? So I'm going to give you, we're going to do number 3, but with an easier equation. So go down to number 3. Number 3. Got it? Okay, and we're going to make this x equals, let's make it 11 minus y squared. Wait, hold on. X equals 11 minus y squared. Okay, trying to pick easy numbers here just so that you can get the concept. Okay, so 11 minus y squared, what would that look like? Opens to the left. Where does it start? What number? 11. So 11's here. Opens to the left. That's x equals 11 minus y squared. What's my next equation? Cross out y equals 0. X equals 2 would be here. Now question, how will I find the points where those intersect one another? Set them equal.
wouldn't x equal 2 be on the other side?
Nope, because this is the y-axis. So this would be like 1, 2. And then 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah? So your region would be here. And then this is the x-axis over here. Okay? Okay, so we said we're going to find the intersections by setting them equal. Can you do that for me, please? So you're letting 11 minus y squared equal 2. Should get whole numbers here. Okay, I would need to move these numbers over here. So my y squared is going to be what on the other side? Positive. And then 2 minus 11 gives me minus 9. How can we factor that? So it'd be plus or minus 3. So this one is y equals negative 3. And this one is y equals positive 3. Is everybody good to there so far? When I set up my integral, those are going to be my boundaries. Okay, what are we revolving around?
Y-axis.
The y-axis. Where's the y-axis?
X equals... No.
Yeah, x equals
0.
0. Am I touching that line already? Here's my region. Here's my line. Am I touching it? No. Right? Okay, so how many r's are you going to have if you're not touching it? 2. You're going to have 1 r from here to here. Is that capital or lowercase r? Capital. And then what about little r? It's going to be from here to here. That's little r. So you have capital R here, little r here. Okay, what is capital R going to be? Right minus left. What's this equation?
11 minus y
11 minus y squared
squared.
minus, if it's the axis, it would be, this axis is 0. So it'd be 11 minus y squared minus 0. Little r, what would little r be? Here to here. 2 minus 0. Good job. And then from there, you would drop the zeros, set up your integral. Where are we integrating from? -3 to 3. Pi in the front. And then your capital R would be 11 minus y squared squared minus 2 squared dy.
Wait, so that vertical line, is it like x equals negative or something?
This is x equals, this is the y-axis. This is x equals 0. Okay? Okay, let's jump up now and do the one right above it. Okay, so 4x under square root, it's just like a normal square root. And then 2x squared is a quadratic, yeah? So those are your two equations. What are we gonna revolve around? What does it say? The y-axis. So when I draw in my r's, if I'm revolving this way, my r's are going to run long r, short r. How do they run? Top minus bottom or right minus left? And if they're right minus left, that means we're doing this one dy. Several things have to change that on the other one were already set up for you. First question, can I use my equations in y equals form? No, so we're going to have to fix both of them. So look at this one. If it's y equals 4x under a square root, how do I get rid of the square root? Okay, so I'm going to square and then divide by 4. So this line right here is now going to be x equals y squared 1/4. That's what we're going to call that graph now. 1/4 y squared. My second equation was y equals 2x squared. What am I going to do first? Divide by 2. And then how do I get rid of the squared? So x equals square root y over 2. So far so good? Okay, then we're going to do our r's. So this is my capital R. What is right minus left for that? Yeah, root y over 2 minus 0. And then what's little r? From that till 0. Now, can I call it y, wasn't it 1/4 y squared? And then minus 0. Now, when I set up my integral, what am I going to need to find for my endpoints? Where those do what? Where they intersect. So I'm going to put volume equals pi integral root y over 2 squared minus 1/4 y squared dy. And then the one other thing we are still going to have to find is where those cross each other. Okay? So we have two choices. We can set these equal to each other, or we can set the originals equal to each other. I say we set the originals equal to each other. So if it's root 4x equals 2x squared, this is to find the intersections. Okay, then I would square both sides. Okay, so root 4x equals 2x squared. Actually, yeah, it'll still work, but it's fine. So square both sides. What's the square root of 4x if I square it? 4x. And then what is 2x squared if we square it? Gotta square the 2 though as well. 4x to the 4. Then get all your stuff on the same side. So it'd be 0 equals 4x to the 4th minus 4x. And then what can we take out of both of those? 4x comes out, you have x cubed minus 1. What is going to make this one 0? 0, and what about that one? 1. So this is x equals 1. Do I need an x value for that? I need a y value, but if I know x, I'm just going to plug in right here. If x is 1, what is y? 1, 2. So then it would be from 0 till 2.
Can we plug it into the other equation?
You could have plugged it into the other one, yeah. And if you did that, you'd get square root of 4, which is still 2. So it doesn't matter. Okay, now look at number 2. All that's going to change is we're going to revolve around negative 2 instead. So let's re-sketch our picture here. This is x equals root y over 2. This is x equals 1/4 y squared. And instead of revolving around the y-axis, we're going to revolve around x equals negative 2. Where would that be on the graph? Would be over 2 back here, right? How is that going to change your radius lines? They're just going to go, instead of stopping here, they're going to go to here. So what would your capital R be? That crap minus negative 2. And what would your little r be? That crap minus negative 2. Does that make sense? But other than that, all the endpoints would be the same, the equations would be the same, and you'd be done. Does that make sense? Okay. So we have like 7 minutes left. So if you didn't already finish yesterday's or Monday's homework, go ahead and maybe work on that. And then tomorrow, I'm going to give you a packet. We'll go through a lot of it together, but it puts area and volume. They're like a bunch of free responses. Okay.